In 2020, a fintech startup auditing their transaction data found several thousand records referencing account IDs that no longer existed. The accounts had been closed and removed from the account service. The transaction service had never been told. Every transaction record was technically valid. The account ID field was populated. The format was correct. The value was the right type. What it pointed to had simply ceased to exist. Customer support teams had been pulling those records up and seeing account IDs they could not resolve. The accounts were gone, the references were not. The transaction service had a foreign key problem, except it had no foreign keys. The accounts lived in a separate database. No constraint linked them. Referential consistency is the requirement that when one record points to another, that reference remains meaningful. Not just that the target exists, but that the thing it points to is still in a state where the reference makes sense. An order that references a product, a message that references a user, a transaction that references an account. The reference implies a relationship. Referential consistency is the requirement that the relationship still holds. This is a broader requirement than foreign key enforcement. A foreign key can verify that a target row exists. It cannot verify that the row is still relevant, still active, or still in a state that justifies the reference. In systems where the reference crosses a database boundary, a different service, a different schema, a different technology, a foreign key cannot verify anything at all. 3 patterns produce referential inconsistency most often. The first is deletion without notification. A record is deleted in one system. Other systems hold references to it. Nobody tells them. This is common in any architecture where multiple services maintain their own databases and communicate asynchronously. The deleting service fulfills its own logic correctly. The referencing services are never updated. The references remain, pointing at nothing. The second is soft deletion. Soft deletion is the pattern of marking a record as deleted rather than removing it. The row stays in the database. A deleted underscore at timestamped or an is_active flag signals it should be treated as gone. From a foreign key perspective, the reference is valid. The row exists, the ID resolves. But the record it resolves to is deleted. The reference points to something that has been explicitly removed from the active dataset. The referencing record has no way of knowing. The third is state change. A record is not deleted. It changes state in a way that makes existing references semantically invalid. A product is discontinued. A user account is suspended. A supplier is marked as inactive. Other records that reference these entities were created when the entity was in a valid state. The entity has since changed. The references have not. They now point to something that exists, but should no longer be pointed to. Each of these patterns produces the same outcome: a reference that resolves to a target, but does not resolve to a meaningful relationship. The data appears intact. The query returns results. The result is wrong. 3 approaches address this. The first is event-driven deletion. When a record is deleted or deactivated, the system responsible for that record should publish an event that other systems can consume. Referencing systems receive the event, locate their own records that point to the deleted entity, and take the appropriate action, nulling the reference, copying the relevant data before it disappears, or flagging their own records for review. This requires an event infrastructure and clear ownership of which systems reference which entities. It is more complex than a foreign key. It is also the only reliable option when references cross a system boundary. The second is validation at read time rather than assumption at write time. Instead of assuming a reference is valid because it was valid when it was written, validate it when it is used. Before presenting an order, check that the product it references is still active. Before processing a transaction, verify that the account it references is still open. This adds latency and requires careful caching decisions, but it catches the failures that write-time validation cannot, the ones where the target changed after the reference was created. The third is reference contracts. In a system where services hold references to entities owned by other services, those dependencies should be explicit and documented. Which service owns the entity? which services reference it, what referencing services expect to happen when the entity is deleted or changes state. These contracts rarely exist by default. They need to be created deliberately. But they convert an implicit assumption into a visible dependency, and visible dependencies can be monitored, versioned, and enforced. The fintech startup addressed the immediate problem with a reconciliation job that identified every transaction record referencing a non-existent account ID. Where the audit log had enough detail, account data was recovered and attached to the transaction records. Where it did not, the records were flagged for manual review. The structural fix was a deletion event. When an account was closed, the account service published an event that the transaction service consumed and used to update its own records accordingly. Several thousand transactions had pointed at nothing for months. Every one of them had been returned by queries without complaint. Referential consistency is not the question of whether a reference resolves. It is the question of whether the thing it resolves to still justifies the relationship the reference implies. Databases can enforce that a target row exists. They cannot enforce that the target is still meaningful, still active, or still in the same system. That enforcement requires events, read-time validation, and explicit contracts between the services that create references and the services that own the things being referenced. Without those, references outlive the things they point to, and the system treats the silence as confirmation.